Good day, my dear learners in the senior high school. Welcome to our another episode of our lesson in mathematics. Today's lesson is all about evaluating function. Here are the following objectives for today's session.
Recall the process of substitution, identify the various types of function, and evaluate the function. Before we begin, there are 5 questions prepared for you and you need to answer each question for 15 seconds. Write your answer in your notebook, then good luck! Choose the letter of the best answer. Write the chosen letter on a separate sheet of paper. In question number 1, which of the following is a polynomial function? I repeat, which of the following is a polynomial function? Timer starts now. And the correct answer is A. Let's proceed to the next question. What kind of function is being illustrated by f of x is equal to absolute value 2x cubed minus 3x plus 5? I repeat, what kind of function is being illustrated by f of x is equal to the absolute value of 2x cubed minus 3x plus 5? Your time starts now. And the answer is D. Let's proceed to question number 3. Find the function value given h of x is equal to 17 plus 8x of x is equal to 4d. I repeat, find the function value given h of x is equal to 17 plus 8x of x is equal to 4d. Your time starts now. And the answer is C. For question number 4, which of the following shows a logarithmic function? Which of the following shows a logarithmic function? Your time starts now. And the answer is B. For our last question, find the function value given h of x is equal to 7x minus 11 if x is equal to 8m plus 3. I repeat, find the function value given h of x is equal to 7x minus 11 if x is equal to 8m plus 3. Your time starts now. And the correct answer is A. Did you get all the 5 questions in this first activity? If yes, very good. If not, do not worry. I have a lot of activities prepared for you.
Before we begin, let's go back to the time when you first encountered how to evaluate expression. Here are the following examples.
Given the following expressions, find its value if x is equal to 3. For our first expression, x minus 9. Since x is equal to 3, we just replace x by 3 in the expression, then subtract by 9. Therefore, the answer is negative 6. For example number 2, 3x plus 7 is the given expression. Following the steps, we just replace x by 3, multiply it by the numerical coefficient 3, then add 7. 3 times 3 is equal to 9. 9 plus 7 is equal to 16. For example number 3, x squared plus 4x minus 10 is the given expression. After replacing x by 3, we get the squared of 3, which is 9. Add it to the product of 4 and 3. Then lastly, we subtracted 10 from its sum. Therefore, the answer is 11. For example number 4, 2x squared minus 6x plus 26. Simply each term inside the parenthesis in order to arrive with 18 subtracted by 18 plus 26. Therefore, the answer is 26. For example number 5, we have 3x cubed minus 6. Get the cube of 3, which is 27, then multiply it to 3, which is the numerical coefficient, to get 81. Then subtract 6. Therefore, the answer in the given expression is 75. Finding the value of x for most of the students is what mathematics is all about. Sometimes, it seems to be a joke for the students to evaluate an expression, like what is shown in the illustration. If you want to learn how to find the value of y, well then, you are in the right page.
We have learned that in an algebraic expression, letters can stand for numbers. And to evaluate an expression, there are two things we need to learn.
First, replace each letter in the expression with the value that has been assigned to it. To make your calculations clear and avoid mistakes, always enclose the numbers you're substituting inside parentheses. The value that's given to a variable stays the same throughout the entire problem, even if the letter occurs more than once in the expression. However, since variables vary, the value assigned to a particular variable can change from problem to problem, just not within a single problem. Second, perform the operations in the expression using the correct order of operations. Once you've substituted the value for the letter, do the operations to find the value of the expression. Don't forget to use the correct order of operations. First, do any operations involving exponents. Then do multiplication and division. And finally, do addition and subtraction.
We also have different types of a function. We have the constant function, identity function, polynomial function, linear function, quadratic function, rational function, exponential function, logarithmic function, cubic function, power function, absolute value function, and greatest value integer.
Constant function. A constant function is a function that has the same output value no matter what your input value is. Because of this, a constant function has the form f of x is equal to b, where b is a constant, which is a single value that does not change. Identity function. The identity function is a function which returns the same value, which was used as its argument. In other words, The identity function is the function f of x is equal to x for all values of x. Polynomial function. A polynomial function is defined by y is equal to a raised to 0 plus a raised to 1x plus a square x square plus a raised to n x raised to n, where n is a non-negative integer, and a raised to 0, a raised to 1, and a square up to a raised to n are elements of real numbers. Linear function. The polynomial function with degree 1. It is in the form of y is equal to mx plus b. Quadratic function. If the degree of the polynomial function is 2, then it is a quadratic function. It is expressed as y is equal to ax squared plus bx plus c, where a is not equal to 0, and a, b, c are constant, and x is a variable. Cubic function. A cubic polynomial function is a polynomial of degree 3 and can be denoted by f of x is equal to ax cubed plus bx squared plus cx plus d, where a is not equal to 0 and a, b, c, and d are constant, and x is a variable. Power function. A power function is a function in the form y is equal to ax raised to b, where b is any real constant number. Many of our parent functions such as linear functions and quadratic functions are in fact power functions. Rational function. A rational function is any function which can be represented by a rational fraction, says p of x over q of x, in which numerator p of x and denominator q of x are polynomial functions of x, where q of x is not equal to 0. Exponential function. These are functions of the form y is equal to ab raised to x, where x is an exponent and a and b are constants. Note that only b is raised to the power x, not a. If the base b is greater than 1, then the result is exponential growth. Logarithmic function. Logarithmic functions are the inverses of exponential functions, and any exponential function can be expressed in logarithmic form. Logarithms are very useful in permitting us to work with very large numbers while manipulating numbers of a much more manageable size. It is written in the form y is equal to log of x to the base b, where x is greater than 0 and b is greater than 0 and b is not equal to 1. Absolute value function. The absolute value of any number c is represented in the form of the absolute value of c. If any function f rs to r is defined by f of x is equal to the absolute value of x, it is known as absolute value function. For each non-negative value of x, f of x is equal to x, and for each negative value of x, f of x is equal to negative x. For example, if f of x is equal to the set of x if x is greater than 0 and negative x if x is less than 0. Greatest integer function. If a function f into real number is defined by f of x is equal to x, where x is an element of x, it rounds off the real number to the integer less than the number. Suppose the given interval is in the form of k and k plus 1. The value of greatest integer function is k, which is an integer. Evaluating function is a process of determining the value of the function at the number assigned to a given variable. Just like in evaluating algebraic expressions, to evaluate function, you just need to replace each letter in the expression with the assigned value and perform the operations in the expression using the correct order of operations. look at these examples. In example 1, given f of x is equal to 2x minus 4. Find the value of the function if x is equal to 3. First, substitute 3 for x in the function. Then simplify the expression on the right side of the equation. So 2 times 3 is equal to 6. And 6 minus 4 is equal to 2. So the answer in the given function 2x minus 4, the answer is 2. For example number 2, given g of x is equal to 3x squared plus 7, find g of negative 3. Substitute negative 3 for x in the function and simplify the expression on the right side of the equation. Since x is equal to negative 3, 3 times negative 3 squared plus 7, and negative 3 squared is equal to 9. 3 times 9 is equal to 27. 27 plus 7 is equal to 34. The answer in that given, g of x is equal to 3x plus 7 is equal to 34. In example number 3, given p of x is equal to 3x squared plus 5x minus 2. Find p of 0 and p of negative 1. Treat each of these like two separate problems. In each case, you substitute the value in for x and simplify. Start with x is equal to 0 and x is equal to negative 1. So 3 times 0 is square plus 5 times 0 minus 2. Therefore, p of 0 is equal to negative 2. While p of negative 1, 3 times negative 1 is square plus 5 times negative 1 minus 2. Negative 1 is square is equal to 1. 3 times 1 minus 5 minus 2. 3 minus 5 minus 2. Therefore, p of negative 1 is equal to negative 4. The answer given p of x is equal to 3x squared plus 5x minus 2, and p of 0 is equal to negative 2, while p of negative 1, the answer is negative 4. It's your turn now. Try to evaluate the following function by filling up the missing parts of the solution. In this example, we have the function f of x is equal to 3x minus 5. Find f of 2. So you are given 15 seconds to answer this. So your time starts now. Time's up. So this is the correct answer in this activity. 3 times 2 minus 5, since x is equal to 2. Simplify. 3 times 2 minus 5. 3 times 2 is equal to 6. 6 minus 5 is equal to 1. Therefore, f of 2 is equal to 1. Great job, everyone! Today's lesson, you recall the process of substitution, identify the different types of function, and solve the given function. Let me ask you one final question. What are the process in evaluating a function? To test your learning in this lesson, I want you to get a piece of paper and answer the given final assessment. For question number 1, which of the following is not a polynomial function? I repeat, which of the following is not a polynomial function? For question number 2, what kind of function is being illustrated by f of x is equal to 3x minus 11 over x plus 7. I repeat, what kind of function is being illustrated by f of x is equal to 3x minus 11 over x plus 7? For question number 3, find the function value of h of x is equal to 9 minus 5x of x is equal to 3m. I repeat, find the function value given h of x is equal to 9 minus 5x of x is equal to 3m. Question number 4. Which of the following shows an exponential function? Which of the following shows an exponential function? And for question number 5, find the function value given h of x is equal to 3x minus 8 if x is equal to 9a plus 1. Find the function value given h of x is equal to 3x minus 8 if x is equal to 9a plus 1. Great job, everyone! We will check your answer to our next meeting. I want you to continue answering the activity in your module, page 10 to 15. Our next lesson will be operations on functions. Once again, this is your general mathematics teacher, Teacher Charmaine, leaving you a message: an investment in knowledge pays the best interest. Stay healthy and follow health protocols. Bye!